Hello friends, welcome to your channel study classes. So in this chapter number 3, that is of 9th class science, so we will discuss about atoms and molecules. What are atoms and molecules? So as you can see here, atoms and molecules, their description here. So you can easily see here an Indian philosopher. There was an Indian philosopher named Maharshi Kannad. He postulated that he thought that there are smaller particles who made atoms, and those smaller particles are to be called as Pramanu according to him, and that cannot be divisible. It means the Pramanu is the last possible smallest matter which cannot be divided into some other matter, okay, some other particles. So here you can see here an Indian philosopher Maharshi Kannad postulated that if you go on dividing matter, it means Padarth, we shall get smaller and smaller particles. Ultimately, a stage will come, we shall came across some the smallest particle beyond which further division will not be possible, and that he named these particles as Pramanu. But later on the science progresses, and we all know that there are many more other particles. We know that Pramanu is divided like electron, proton, neutron. Beyond that there are electrino, protino, neutrino, antineutrino, and something more like that. So in this chapter we will cover only up to atoms and molecules, how this made, what are the particles which made up atoms. So let's move to the next slide, that is the description of the atoms. See, there are many scientists who derived the atoms according to their perception or postulated. There was Democritus and these two scientists there. They suggested that if you go on dividing a matter, a stage will come that it cannot be further divided, and those particle is called atom, okay. And here you can also see Antonio Lavoisier led the foundation of chemical sciences by establishing two important laws of chemical combination. See, at that time there was very misconception was spreading across all over the science community, what is atom, what is molecules. So these scientists try to discover the atoms, molecules, their definitions, how they formed. So Antonio Lavoisier had given two laws, basically two important law of chemical combination, that okay, now we got atoms, how atoms combine each other to make some other particles, some other portions of some other elements. So the two laws are laws of conservation of mass first, and second one is law of constant proportions. There I have mentioned here laws of conservation of mass and law of constant proportions. So first law is law of conservation of mass. What does this mean? It means that mass can neither be created nor be destroyed in a chemical reaction. It means if there is a chemical reaction happening between two elements, I am using here element for your better understanding. If there is chemical reaction happening between two elements, the mass will be remain same throughout the reaction, whatever the product will be there. See, you can see here in your bookish language, law of conservation of mass states that the mass can neither be created nor destroyed in a chemical reaction. According to law of conservation of mass, the mass of the product in a chemical reaction must equal to the reactants. What does this means? See here, methane, you can see here methane CH4, and his mass is 16 gram. I have put an arrow here, 16 gram, okay, is reactant with oxygen. Two oxygen molecules is there. So the mass of one oxygen molecule is 32 gram. I will tell you later how this 32 gram arrived. So multiplied by 2, it's equal to around 64 gram. So that the product was carbon dioxide plus water. And if you add these two masses like 16 gram plus 64 gram, it equals to these two masses. 64 plus 16, that is 80, and here you can find 18 into 236 and 44, 80 gram. So the reactant and the metal atoms reacting, the mass of both will be equal. Mass can neither be created nor be destroyed. This is the first law of conservation of mass, okay. Now second was law of constant proportion. What does it means, law of constant proportion? It means if a chemical substance or a element is reacting in a definite manner, say like you can take an example like mass of hydrogen, okay, is always constant in a water, whatever source you take, like you take some alkaline water, you take some hand pump water, or you take some that tap water, the mass of hydrogen and oxygen in that whole over water compound will be remain same throughout any source of the water. And this law was stated by Proust as law of definite proportion. So law of constant proportion, we called it law of definite proportion. What does it means? In a chemical substance, the elements are always present in a definite proportion by mass. Here is an example of that. See here, you can see water. In a water, in the water, the ratio of mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 gram of water is decomposed, if 9 gram of water is decomposed, if we decompose it, means we boil it, 9 gram of water, 1 gram of hydrogen and 8 gram of oxygen are obtained, always obtained. So let's move to the next topic, that is atomic theory. See, all this were done by this scientist. Lewis has formulated his postulate. So now Dalton came up with his theory of atomic. See, in an atom, we all know that Maharshi Kannad told there was Pramanu. Okay, so Dalton made some assumptions that okay, so make a whole theory regarding this laws, and thus make a complete theory to understand this matter, how it is made, water revolving around it. So he made just theory. Okay, what was his theory? See here, there was a huge chaos because there was no definite law and practical method was present of validate these law. Hence, all this was assumption. The main assumptions of Dalton was all the element are made up of atom. Okay, we cannot divide them further. The first assumption of this, see, Dalton's atomic theory was on totally assumptions basis at that time. So first assumption he was done that key elements are made up of atom and we cannot divide them further. But we all know that there are his theory is totally wrong. At that time it was correct, but now we know that his theory was wrong, because we can divide that atom into electron, proton, neutron. Before that electrino, protino. After that electrino, protino, neutron, and some other like quarks and other more particles. So first his assumption was any element was made up of atom and we cannot divide them further. All matter is made up of tiny particles called atoms which participate in the chemical reaction. He tell that all matter is made of tiny particle called atoms which only participate in chemical reaction. If there is chemical reaction happening between two elements, there are the atoms who are taking part in the chemical reaction. Okay, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. It means the atom of let's say here we take oxygen and hydrogen. See, if we atoms of hydrogen and oxygen are reacting to form water, in that water you will find the atoms of oxygen and hydrogen. You will not find the atoms of H2O. There are the atoms of hydrogen and oxygen will be present there separately. Atoms of a given element are in decline mass and chemical properties. It means, what does this mean? If a given elements, atoms of a given elements are identical in mass and chemical properties, like oxygen and hydrogen, they are identical, both are gases. Okay, atoms of different element have different masses and chemical properties. Here you can see different atoms have, of course, will be different masses according to the electron and proton proposition. So, and they will show also different chemical properties because of their octet. You will learn further what is octet, what is valency. I will describe you all these things one by one. Here you can see the relative number and kinds of atom are constant in a given compound. These all are assumptions which Dalton made. The point is the relative number and kinds of atom are constant in a given compound. I already described you. Atoms combine in the ratio of small whole number to form compounds. As we all know that the ratio in which they compound are the whole numbers. You see, it can't be fraction like 1.2, 1.3. It's to be whole number, so that the compound should be formed and it has the mass, exactly the mass equal to the reactant. Okay, and the mass of the reactant always taken into consideration as a whole number, not in a fraction. So what is atom? The building block of all matters are atom, as we all know. Means till the Dalton's atomic theory, the assumption was atom is the building block of all matters. Okay, so here are some symbol on which you will describe that uh, Berzelius suggested that the symbol of element be made from 1 or 2 letters of the name of the element. There are around 110, 112 elements in our periodic table. You will know later on the classes what is periodic table. So how we categorize them, how we symbolize them. So Berzelius suggested that the symbol of the element should be 2 letters of the name of the element. Like in oxygen, it is only O, but in certain cases like copper, gold, it is Ag, silver, Au, like this. So there is a committee that is International Union of Pure and Applied Chemistry. It is an international scientific organization which approves the name of the element, symbol and units. Here it is just the size of the atom, that doesn't matter for you right now. Okay, so at that time there was no such rule there to regulate and monitor the name of the element. Okay, when the Dalton's theory was proposed, there was no such rule or regulation or the authority is there to regulate the name of the element or the atoms. So here you can see the symbol of aluminium is Al. The first letter, I have told you the first 2 letters, that is A and L. Argon Ar, barium Ba, boron B. So here all these elements, just to refer, you have to at least memorize 30 elements, their atomic number and atomic mass. So now let's move to the next topic, that is atomic mass. What is atomic mass? The most remarkable concept that Dalton's atomic theory proposed, that of atomic mass. According to him, each element had a characteristic of atomic mass. What does this mean? This means that there is something in that atom which carries all the properties of the atom, and that is to be that atomic mass of that atom. Okay, see, there are some subatomic particles beyond atom also, like electron, proton, neutron. At that time they do not know about that, but they assume that atom have its own mass. Okay, they assume that atom have its own mass, so they told that atom have atomic mass, and it is now written as a U, unified mass, equal to the mass of one carbon atom. Okay, so you can see here the atomic mass of hydrogen is 1, carbon is 12, nitrogen is 14, oxygen is 16. You have to remember at least 30 up to 30 elements. The atomic mass of the here I have given only few elements. These are table given from a book only. So if you need, I will provide you the PDF for all these atomic mass and atomic numbers for these elements. Now in 1961, atomic mass was universally accepted. Okay, everybody was accepting atomic mass. What is the mass unit of the atomic mass? That is carbon 12 isotope was chosen as the standard reference for measuring atomic masses. So one atomic mass unit is a mass unit equal to exactly 1/12 the mass of one carbon 12. Okay, so see, if I have to describe the mass of one atomic unit, okay, so I have to give that in the form of 1/12 of the one carbon 12 atom. That is the relative atomic masses of all elements, and these are derived from that only. These atomic masses are derived from that only method. Okay, now the next topic is molecule. Okay, atom was done and dusted. Now the next topic is molecule. See, after atom, in this book it is not given, but after atom you should learn about that the subatomic particles like electron, proton and neutron, but according to the book we will go through. So after atoms, here it is molecule. What is a molecule? A molecule is generally a group of 2 or more atoms that are chemically bonded together. Okay, and they are, by which they are bonded by some attractive forces. There are some forces which bonded that molecules to form atom. A molecule can be defined as the smallest particle of the element of the compound that is capable of independent existence and shows the property of the substance. It means, you can take example of salt. Okay, salt, if you take one pinch of salt, it will show all the properties of the salt alone, independently. That is something more or less about molecule. So here we can see the number of atom consisting a molecule is known as atomicity. It means, see here, ozone, the formula for the ozone is O3. It means there are 3 oxygen particles present in there, 3 oxygen molecules, sorry for using particle, 3 oxygen molecule is present there. Oxygen O2, it means it is a diatomic, and the number of atoms constituting a molecule is known as atomicity. Okay, so this is for your examination purpose. If the definition come what is atomicity, you can write down this definition. Now what is ion? Okay, the next point is what is ion. So here we can see compound composed of metals and non-metals. Okay, there are charges. See, that's why I'm saying that they should provide electron, proton and neutron so that you can learn the charges of that. Anyway, these are given ions. Okay, the charge species are known as ion. See, some elements in our periodic table, in our whole world, there are some elements, many more elements to be discovered. There are around roughly 120 elements, so in which they have some positively charged and some of them are negatively charged. Okay, so the charge species are known as ions. Ion may consist a single charge atom or a group of atom. Okay, example here NaCl. Here you can see Na, that is sodium, has a positive charge, so we call it cation, and chloride has a negatively charged and we called it anion. There is 2 charged particles, that is cation and anion. So these are ions, we basically called it ion based on these positive charge. How we tell that sodium is positively charged? Because of the electron present in that. But in this chapter we are not going to discuss about electron, proton or neutron. So let's move to the next slide, that is writing a chemical formula. Okay, now I know atom, I know its ion, I know its atomicity. Then how can we write a formula for the compound? How can we write a chemical formula? Okay, so what is a chemical formula? A chemical formula is of a compound is a symbolic representation of its composition. It means when you write a chemical formula for some compound, it represents the atoms present in that of any element. Like methane, like you can see a shorter format, that is for water. You can take water, it has H2O. It means there are 2 oxygen molecules, 2 hydrogen molecules and 1 oxygen molecule. So for hydrogen molecules we have written 2, and for oxygen we have written only O. There is nothing 1 or 2 mentioned there. Okay, so how we know that these have the element of the power to means to have a reaction with other element? So there is a term called valency. Okay, what is valency? Valency, if you study in the deep, it is everywhere, present in everywhere. In nowadays we also want, you are listening this lecture just to clear the examination, to settle down. This is the rule of the world. We are working hard to earn money, to settle down and to be peace minded. So atom also want that. They have some free elements also want that. They have some free atoms, and which element want that? Okay, let it give it or take it and complete my octet. Octet means, it means the last cell of the atoms will have 8 atoms, or I can't say electron here because I have not told you about electron, proton and neutron right now. So I can just using this simple languages. Valency can be used to find out how the atoms of an element will combine with the another atoms of the element to form a chemical compound. Here is a law of octet. I already described you. Every element in this earth tries to complete its octet. Octet means the last orbit have 8 electron again I am saying 8 atoms. Okay, so this is law of octet. So the writing of chemical formula will have a few more points. Here you can write down the points, that is the valency or the charge on the ion must balance. See, if the charge of NaCl is plus and Cl is minus, that to be balanced in the reactant also, a product also, that is NaCl salt also, you can't left them apart. Okay, when a compound consists of a metal and a non-metal, the name or the symbol, the metal is written first. Like see, if there is a combination of 2 metal and non-metal, okay, so the product shall have metal first. Here you can see sodium chloride, where oxygen, chlorine, sulfur are non-metals are written on the right. Here see calcium oxide. Okay, metals are written first and then non-metals are written second. Okay, These are the example of that. In compounds formed by polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in brackets and writing the number of ion outside the bracket. For example, MgOH2. OH2 means there are two ions of each, for oxygen also and for hydrogen also. So we can't write the formula like MgO2H2. So for this we only write MgOH in bracket and then whole 2. It means this 2 will be multiplied with O also, and this 2 will be multiplied by H also. In case the number of polyatomic ion in 1, the bracket is not required. The bracket is only required if the number is greater than 1. It will be 2, 3, 4, 5, anything. Example, NaOH. We can't write, we will not writing OH in the bracket. Okay. So these are few points you can see here. Like see formula number 1, hydrogen chloride. See symbol here, hydrogen chloride. Valency of hydrogen is 1, valency of chloride is 1. So 1H and 1C. So here HCl, because we have to write metal first, chloride second, we have HCl. Formula of hydrogen sulfide, same here, H valency 1 and sulfur valency 2. So their cross multiplication happened and formula is H2S. Okay. So there are few examples. Note what we have to note here. We use bracket when we have two or more of the same ions in the formula. Example, formula of calcium hydroxide, CaOH2. I have told here we have to write like this, CaOH whole twice. We can't write this, that CaOH into 2. That is the wrong representation of the chemical compound symbol. So next topic is our molecular mass and mole concept. What is molecular mass? The molecular mass of a substance is the sum of atomic masses. And what is atomic masses? It is the mass of the atom equals to the 1/12 of the carbon 12 atoms. Okay. So the molecular mass of a substance is the sum of atomic masses of all the atoms in a molecule of the substance. It is therefore the relative mass of a molecule expressed in atomic mass. It is just a relative mass. It means all the atoms of the molecules have their masses and we have to combine them, and that became molecular mass. Example you can see here, calculate the relative molecular mass of the water, that is H2O. Okay. So here atomic mass of hydrogen we know that is 1, oxygen we know 16. So the molecular mass of water, which contains 2, because here H2, so it will be 2 point of hydrogen, that is 2 atom of hydrogen, and 1 atom of oxygen. So 1 multiplied by 2, that is 2, plus 1 multiplied by 16, that is 18. Here you can see HNO3. HNO3, what is the molecular mass? Here O3 has 3. Okay. So H, as we know, 1, the mass of hydrogen is 1, and nitrogen 14 plus oxygen 16 into 3, 48. That is total is equal to 63. So this is the basic fundamental to calculate the molecular mass of the substance. We have to divide them separately and multiply with them with the number of the ions to their atomic masses, and then sum of all them is equal to the molecular mass of the substance. Okay, the formula unit mass of a substance is a sum of atomic masses. We all discuss here. See, calculate the formula unit masses of CaCl2. What does it mean? It means the atomic mass of Ca plus 2 into C atomic mass of Cl, that is chloride. Sorry. So as we know here, we can infer from the above equation that the quantity of a substance can be characterized by its mass or the molecules. But a chemical reaction equation indicates directly the number of atoms or molecules taking part in reaction. It means if we by seeing that the molecular formula, we can found that which chemical or which atom, sorry for the chemical, which atom is taking part in the reaction. So there was a new unit, mole, was introduced for the sake of the atom to describe their mass. See, what is mass of atom? As we have to combine all the unit, and then we have to then we will move to the conclusion. So okay, this is atoms, and we combine all the masses of their atom, then we will reach to the atomic masses of all the atoms. But mole is a concept. What is a mole? Here you can see rather than, so a new unit mole was introduced. The mole symbol, mole, is the SI unit of amount of the substance. So okay, it is an amount, it is not the mass of a substance, it is the amount of the substance present in 1 molecular mass. So what is 1 mole? 1 mole is equal to 6.022 14076 into 10 to the power 23 elementary entities, and this number is known as Avogadro number, because a scientist name as Avogadro has discovered this. So this number is known as Avogadro number. So you have to write down Avogadro number, you have to memorize this number, because it will come in numericals, and you have to solve these numericals also. So this is all these things regarding this. The mass of 1 mole of a substance is equal to its relative atomic or molecular masses in gram. Avogadro number was named in the honor of Italian scientist Amedeo Avogadro. So thank you very much for listening my lessons. If there are some demerits, you can also you can comment me and give me your feedback regarding that. Words I am using, those words I can change those words also. If you want some technicals in Hindi, I can also tell you in Hindi also. If you want English, then it's okay, I will try to improve my English also. So basically this is the just a theory notebook for your chapter 3, and the next video I am just giving after 2 or 3 days after this video will be your numerical basis for all these chapter 1, chapter 2, chapter 3. All these videos have been provided to you, the I button link for chapter 1 and chapter 2. So the next video will be the numerical for chapter 1, chapter 2 and chapter 3, because in physics, chemistry or anything, numerical is very important to understand and to learn the concept. Okay, so till now, take care, have a good day, and please subscribe my channel. Please do share with your friends, among your friends, and please comment and give your feedback so that I can improve myself. Thank you very much.